Welcome to the series of videos where we solve the questions in the 2026 WASSCE Elective Maths Paper 1. In this video, we solve questions 21 to 30. As usual, you can find more material for revision and practice on our website, preppyonline.org. Question 21. If 1 plus 2x all to the power n is equivalent to the square root of 0.98, what are the values of x and n? So here we're going to try to write this quantity in a form that is like this. So that 1 plus 2x to the power n. If we can write this in this form, then we can extract the values of n and x. So the first step we take is that this 0.98 is equal to 1 minus 0.02. So that's the first step. And then square root is equal to, taking the square root of something is the same as raising it to the power half, or 1 over 2. So when you write that, then if we want to change the minus to a plus, we can say that, well, this is 1 plus, and we also have 2 here, but let's first work with the plus. Or if we want the 2, we can say, if you pull out a plus 2, then you have a minus 0.01, and then you have your power half outside. So let's just check. We have this 1 here, we have the 1 here, then we have 2 times minus 0.01, and that gives you minus 0.02. And then this half here is also here. So indeed, this is equal to that. And remember, this is equal to the square root of 0.98. So now I want to compare these two things. And when you do, you have your 1 here. Let me use a different color. You have your 1 here, you have your 1 here, you have your plus here, you have your plus here, and then you have your 2x here. Here too, you have 2 times something, and you have your n here, you have your half here. So what does that mean? It means that n is equal to half, because that's the exponent. The exponents are the same because the bases are the same. And we say the bases are the same. That means that x is equal to minus 0.01. So looking at the answer options, what do we have? We have that the answer is A. Question 22. P is equal to 2i minus 7j, and Q equals xi plus yj, and P plus 3q equals I minus 5j. Find the values of x and y. So what do? We have P plus 3q. These are vectors. Let's not forget that. So P is equal to what? Is equal to 2i minus 7j. And then we can put all of this in one set of brackets. And then we have plus 3 times. Now Q is equal to xi plus yj. All right. So we simplify the right-hand side. What do we get? We can write this as 2i minus 7j plus 3xi plus 3yj. So we put all the expressions in I together, or all the vectors in I together, and all the ones in j together. That gives us, for the i's, we have this one. Use a different color. We have this one and this one. And for the j's, we have this one and this one. So putting them together, what do we get? We get 2 plus 3x. That's for the i's. And then for the j's, what do we have? We have minus 7 plus 3y. That's for the j's. So we have something I plus something j, and that's supposed to be equal to I minus 5j. So here we can put I minus 5j. So this is equal to that. If that is the case, then comparing coefficients of I and j, what do we have? We have that 2 plus 3x. Let me write the plus well. 2 plus 3x is equal to 1. You can call this the coefficient of I here. The coefficient of I on the left-hand side is 1. So if we equate that to the coefficient of I on the right-hand side, we have 2 plus 3x is equal to 1. So that gives us this equation that we have to solve. Let's call it equation 1. And then comparing the coefficients of j, we have minus 7 plus 3y is equal to the coefficient of j on the left-hand side is minus 5. So we can call that equation 2. So we want to solve these two equations. Well, over here, what do we have? We have 3x. 3x is going to be equal to 1 minus 2, which is minus 1. That means that x is equal to minus 1 over 3. And then over here, what do we have? We have 3y is equal to 7 minus 5, which is 2. So y equals 2 over 3. So looking at the answer options, what do we have? We have C being x equals minus 1 over 3 and y equal to 2 over 3. So that's our answer. Question 23. We have f of x plus 1 is equal to some expression, and we are supposed to find f of 2. So if we have f of x plus 1 and we want f of 2, the question is, what do we do to this x plus 1 to get 2? Or what value of x is going to make this whole thing f of 2? And the answer is, when we set x equal to 1, when you set x equal to 1, then f of x plus 1 is going to be equal to f of 1 plus 1, which is equal to f of 2. Yes, so if you have f of x plus 1 equal to this quantity, 2x squared minus 4x plus 2, then f of 2 is what you get by putting in x equals 1. So what do you get when you put in x equals 1? You get 2 times 1 squared minus 4 times 1 plus 2. And what does that give you? 1 squared is 1. So we have 2 times 1, which is 2. 4 times 1 is 4. So minus 4 times 1, minus 4, plus 2. So we have 2 minus 4 plus 2, and that is equal to 0. So our answer is A. Question 24. Find the minimum value of y equals x squared plus 2x, x squared plus 9x minus 17. So this is a quadratic, and we know that quadratics have this shape. If you draw the curve of a quadratic, you're going to get something like that. You could also get something like this, but in this case, the coefficient of x squared is positive. When the coefficient is positive, you're going to get this shape and not this shape. So the shape is something like this. And so that's why it has a minimum. The minimum value is going to be at the vertex at the bottom here. And the question is, what is that minimum value? Well, we can use a number of approaches. As you can tell, the minimum value, this is one fact about parabolas of this type. The minimum value is going to occur on what we call the axis of symmetry. The axis of symmetry is the line that divides the parabola into two equal parts. So whether you have a maximum or a minimum, in this case we have a minimum, but whether it's a maximum or minimum, it's always going to be on that axis of symmetry. So if you could find the x value that on which the axis of symmetry falls, then the y value that corresponds to that x value is going to be your minimum value. So that's one way to do it. And if you remember from your your studies, the axis of symmetry happens or occurs at the value x equals minus b over 2a. And its value, the value at that place, is f of minus b over 2a. That means that if you write the general equation of a quadratic as ax squared plus bx plus c equals 0, that's where the a and b is coming from. So whatever your b is and whatever your a is, if you take minus b over 2a, your axis of symmetry is going to be on that line, and its value, the minimum value or the maximum, in this case we are dealing with the minimum, is going to occur at this value. So what is our b in this case? In this case, our b is equal to 9. B is the coefficient of x, and our a is equal to 1. A is the coefficient of x squared. So minus b over 2a is equal to minus 9 over 2. So the question is, what do you get when you substitute minus 9 over 2 into this equation? So we get y equals, here our x is minus 9 over 2, so minus 9 over 2 all squared plus 9 times minus 9 over 2 minus 17. So if we calculate this expression, let's do it. 9 squared is 81. So we have 81 over 4. The minus goes away. Then here we have 9 times 9 again is 81. So over 2, this one is minus, not plus. We have to be careful with the signs here. So here is minus. All right, minus 81 over 2. Then we have minus 17. All right, so here we have to do a bit of arithmetic. You can punch this into your calculator, but if you want to do it by hand, you can write this as 81 over 4 minus, if you want to write this one also over 4, then the numerator, let me get rid of this line so we don't get confused. The numerator is going to be twice that. So twice 81 over 4. And then we have 17. We can write that one also over 4, or we can do it in another way. I think we can try to write that over 4. If you do that, then you're going to get 4 times 17 here. All right, so we have 81 over 4. Okay, let's simplify that. This is equal to this minus 81 times 2 is 162 over 4. Then we have 17 times 4 is 68. So 68 over 4. All right, so we have to do some subtraction. Let's see. We have 81 here. We have minus 162. We have minus 68. So let's add the 162 to the 68 and see what we get. We get 0. 6 plus 6, 12, 13. So we get 230. So that's minus that. And we have that plus 81. So basically this is equal to 81 over 4 minus 230 over 4. All right. So we have to solve this, we can write it this way. If you write 230 minus 81, then you take the negation of that, or the negative of that. So here we get 9, and here we get 22 minus 8. That gives you 14. So we have minus 149 over 4. So that gives our answer as D. Now we had to do a lot of arithmetic here. You don't have to do this in an exam. You can just punch at this stage. Most calculators can do this in one step. So if you punch this into your calculator, you'll immediately get the final answer. We just wanted to do it by hand to see what was going to happen. And when you're working on your own and it's not a real exam, you can always practice by doing it this way and then checking your answer on the calculator. All right, so this is one method of doing it. I mentioned that we have other methods. For instance, you could use calculus to do this. Whenever you hear minimum, maximum, and things like that, you should think about calculus. And so you can differentiate and so on. Let's do that. We may not do the full thing, but let's see. So we have y equals x squared plus 9x minus 17. So dy dx is equal to what? Is equal to 2x plus 9. So what we know from calculus is that the minimum or the maximum, whatever critical point there is, must occur when the derivative is equal to 0. So what happens when the derivative is equal to 0? We have 2x plus 9 is equal to 0, and x equals what? Minus 9 over 2. So here you see we've got the same 9 minus 9 over 2 that we got from this. So that tells us that this is going to give us the same answer, because this computation is showing us from calculus that the minimum occurs when x is equal to minus 9 over 2. And we just calculated that when x is minus 9 over 2, we get minus 149 over 4 as the answer. So calculus is going to give us the same answer that we got by using the axis of symmetry. Another method that we can use is completing of the square. If you complete the square in this exercise, you're automatically going to find the minimum. So let's try to do a bit of that. Maybe we'll not do the full thing, but let's see. To complete the square, we write this x squared plus 9x minus 17. And to complete the square, we add half the coefficient of x, the square of that. So we have x squared plus 9x, and then we add half of the coefficient of x is 9 over 2. We square that, and then we have our original minus 17. But then, because we've added this quantity, we have to subtract it if we don't want to change what the original expression was. So that's a little trick, but it's not really a trick. It's an equation, if you like, because if you think of it as an equation, then this is our left hand side and this is our right hand side. So now look at what's on the left hand side. We have x squared. Okay, on the right we have x squared. We have 9x. On the right we have 9x. And we have minus 17. We also have minus 17. The only difference is that now we have this expression and that expression. So if you have plus 9 over 2 all squared and you have minus 9 over 2 all squared, those two are going to cancel out to give you 0, so that your left hand side is equal to your right hand side. That is why we have to subtract we have to subtract 9 over 2 squared. All right, so what is this equal to? We write this as x plus 9 over 2 all squared, and then we have minus 17, and then minus the square of 9 over 2. All right, so this expression is equal to this expression that we've been given, or this one, the same thing. And so the question is, what is the minimum? Can we, from this, find the minimum? And the answer is yes, because we are going to use an idea about squared numbers. You have this x plus 9 over 2 all squared. So this one depends on the value of x. And then you have here minus 17 minus 9 over 2 all squared. This does not depend on x. This is a constant. No matter what the value of x is, this expression, no matter what the value of x is, it remains the same. But this one, it depends on the value of x. And so the one that we can do something about is the one that depends on the value of x. And the question is, if you want to minimize this whole expression, what should be the value of x? Here, if we notice that when you square a number, the smallest that it can be is 0, then the question to ask is, what is going to make this 0? If you have the function f such that x goes to x squared, the graph of this function looks like this. You have your y-axis, then you have your x-axis, or your line y equals 0. Now, every value, no matter what the value of x is, the value of y is going to be positive, even if x is negative. So that's the idea, that the square of a number is always positive, even if the number itself is negative. For instance, the square of minus 3 is positive, or plus 9. Minus 3 times minus 3 is plus 9. So the square of every number is always 0 or greater than 0. It is never negative. So if you want to make this as small as it can get, the best you can do is to make it 0. And how do you make it 0? You make it 0 when x minus 9 over 2 is equal to 0. And that implies that x is equal to 9 over 2. So here we've encountered this magical x equals 9 over 2 again. Sorry, so this is plus, this should be minus. X equals minus 9 over 2 again. And remember, that's the same quantity we got when we used the formula for the line of symmetry. And we got the same thing when we used calculus. So this is telling us that the minimum of this quadratic, or this expression, is going to occur when x equals minus 9 over 2. And so if we find f of minus 9 over 2, or the value of y, let me write this well. If you find the value of y, so find y when x equals minus 9 over 2, you will get your minimum. And we've already done this. We've done this twice already. So we know that if you put x equals minus 9 over 2 in this expression, you're going to get minus 149 over 4. Question 25. Given that 1 plus the square root of the square root of 3y minus x root 3 is equal to 5, find the slope of the line. So to find the slope of the line, we know that if you write the equation of a line as y equals mx plus c, then the slope is m. So we're going to try to make y the subject. And to do that, what do we get? Let's start from what we are given. We're given 1 plus the square root of 3 times y minus x root 3 is equal to 5. You're trying to make y the subject. All right, let's write this. So 1 plus the square root of 3 times y is equal to what? 5 plus x root 3. So we divide both sides by this coefficient. And what do we get? We get y is equal to 5 plus x root 3 all over 1 plus the square root of 3. All right. Now, at this stage, we really do know the coefficient of x. The coefficient of x is going to be this quantity. It's going to be this square root of 3 over 1 plus the square root of 3. So if this were one of the options, we could have stopped here. But unfortunately, they didn't give us that as one of the options. And that gives us a hint that we should rationalize the denominator of that surd. So right now, from this, we are contending that the slope is the square root of 3 over 1 plus the square root of 3. That's the coefficient of x. So now to rationalize, we're going to multiply both the numerator and the denominator by the conjugate. So we have the conjugate of the denominator. The denominator is 1 plus square root of 3. So the conjugate is 1 minus the square root of 3. So we multiply by 1 minus the square root of 3 over 1 minus the square root of 3. When you do this, what do you get? You get square root of 3 minus square root of 3 times square root of 3 is 3 minus 3. And then here you have in the denominator a difference of 2 squares. So you have 1 minus the square of the square root of 3, which is 3. So you're going to get this. And what is this equal to? We have the square root of 3 minus 3. And then in the bottom, we have minus 2. So what is this equal to? If we want to write them as two separate fractions, we get minus the square root of 3 over 2 plus 3 over 2. So looking at the options, D is looking like what we are looking for. So we just write it again. We put the 3 over 2 first, and then square root of 3 over 2 is the same as half of square root of 3. So if you write it this way, then it's clear that our answer is D. Question 26. Given that P is the complement of Q, where P and Q are subsets of the universal set mu, which of the following is not true? So we have that P, let's write that, P is the complement of Q. That means that P is equal to Q complement. Now, because complement is a symmetric relationship, if P is the complement of Q, that means that Q is also the complement of P. This statement implies the statement. All right, so using these, we want to check which of the following, which of the statements we're given is not true. And looking at the options, the first one says that P complement union Q complement equals P intersect Q. Here we get a sense of De Morgan's laws. Let me refresh our memories. De Morgan. So De Morgan's laws state that if you have, let me write it this way. Let's say you have P union Q. If you take the complement of this, the laws say that this is equal to P complement intersection Q complement. And if you have this as well, this is equal to P complement union Q complement. So these are two statements from De Morgan's laws, and they're going to be helpful here. What it means is that something like A, right? Here A is given as P complement union Q complement. Now, remember, we don't have a complement outside here. But if we did, then this would be equal to P intersect Q. So this is a rather interesting statement we're given. We are told that this P complement union Q complement is equal to P intersect Q. However, what De Morgan's law are telling us is that it's rather the complement of that that is equal to P intersect Q. So immediately we suspect that A is not true. So let's confirm that indeed it's not true. For A to be true, this statement, because we have said that this, the complement of this is equal to P intersect Q, we have to show that for A to be true, we need that P complement union Q complement. We need that also to be equal to P intersect Q. So basically, we need this statement and its complement to be equal to the same thing. In other words, we need this to be equal to its complement. And the question is that possible? Is it possible for a statement or for a set to be equal to its complement? You have a set like that. Let's say you have some universal set and you have some set like this and you have its complement. The question is, can the complement, which is what is outside, can the complement be equal to what is inside? And the answer is no. The complement of a set cannot be equal to the set. So A is wrong. A is false. All right, let's look at B. B says P intersect Q complement. The complement of that. Again, by using De Morgan's laws, P intersect Q. If you want the complement of that, it's equal to P complement union Q complement, not P union Q. Let me see. No, sorry. Yes, that's right. So we have to now see whether this is equal to that. Well, because we are told that P equals Q complement and Q equals P complement, we can write this as, if we write P complement as Q and we write Q complement as P, then indeed we have this is equal to Q union P, which is equal to P union Q. So B is correct. Again, the fact that we used, so this, in moving from this step to this step, we used De Morgan's laws. And then in moving from here to here, we use the fact that we're given P equals Q complement and Q equals P complement. And then in moving from here to here, we use the fact that union is commutative. That means that when you're taking the union of two sets, it doesn't matter. A union B is equal to B union A. So here we used De Morgan. And then in the second step, we used definition, or yes, let's say given info. We use the given info. And in the third step, we use the fact that union of sets is commutative. All right, let's look at C. P intersect Q is empty, or the empty set. P intersect Q, well, we are given that P is equal to Q complement. So if we now replace P with Q complement, we have Q complement intersect Q. And indeed, the intersection of a set and its complement is the empty set by definition. If you have a set, remember that the complement of a set is the things that are outside the set. So the things inside the set and the things outside, there cannot be an intersection between them. All right. What about, so C is correct. What about D? P union Q. So P union Q, we are being told, is the same as the universal set or the full set. So here the idea we use, if we write that P, we are told that P is equal to Q complement. So this is the same as Q complement union Q. Now Q complement union Q is indeed the full set, because if you have this as your full set or your universal set and you have this set inside of it, then the union of this Q, so let's call this Q, the union of this Q and what is outside of Q. So let me shade what is outside of Q. This is what's outside of Q. It is true that, it is indeed true that the union of what is inside Q and what is outside Q is the universal set. So D is also true. So it's only A that is not true. The rest are all true. Question 27. A particle is acted upon by forces F1, given as that, F2 and F3. Find the force required to keep the particle in equilibrium. So here the idea we use is that when you have forces in equilibrium, their sum is equal to 0. So sum of forces in equilibrium is 0. So if we are being asked to find a force, let's call that force F4. We are calling it F4 because we have F1, F2, and F3. So if some force F4 is the force required to keep the body or the particle in equilibrium, then we are saying that F1 plus F2 plus F3 plus F4 is 0. What does that mean? It means that F4, which is what we're looking for, is equal to negative F1 plus F2 plus F3. So we can find F4 by adding the three forces we've been given and taking the negation or the negative of that. So let's add the three forces. What do we get when we add the three forces? We have 7, 3 plus 3 minus 1 plus minus 2, 5. When you add these three, what do you get? On the top, you get 10 minus 2, so you get 8. On the bottom, you get 8 minus 1, so 7. So if F4 is the minus of this, then F4 is equal to minus 8, 7, which is the same as minus 8 minus 7. So the answer is B. All right, question 28. Calculate the coefficient of x to the fourth, y to the third in the binomial expansion of that. So the general term in the binomial expansion of that can be written as this: n choose r, or n combination r, times, you can write it as this term 2x to the power r, then you have minus y over 2 to the power n minus r. But here n is 7. So all right, so let me just substitute the correct values for n and r. So here we are going to use n equals 7. That's this value. And then we're going to use r because x is 4. R is the value of the coefficient, sorry, the power of x. So r is equal to 4. So we write 7, choose 4. Then we have 2x to the power 4. We have minus y over 2 to the power 7 minus 4. So this is equal to 7 choose 4. We have 2x to the 4th. And then we have minus y over 2 to the 3rd. So simplifying this, what do we get? This quantity 7 choose 4 is equal to 7 factorial over 7 minus 4 factorial over 4 factorial. And what is this equal to? It's 7 factorial over 3 factorial, 4 factorial. And what is this equal to? We can write this as 7 times 6 times 5 times 4 factorial over 3 factorial times 4 factorial. So when you simplify, this cancels. Then you have 765 over, or 7 times 6 times 5 over 3 factorial. 3 factorial is equal to 6. So we have 7 times 5, which is 35. So we substitute that value into what we have here. We have 35, that's 7 choose 4. Then 2x to the power 4 is 16x to the power 4. Then you have this minus y over 2 cubed is going to be minus y cubed over 8. So we simplify this further. What do we get? Mind you, is the coefficient we are looking for. So when we have y cubed here and we have x to the 4th here, all we care about is these coefficients. We have to get these coefficients right. So we have 35 times 16 over 8, or minus 8. Let me put it here. And we have x to the 4th, y to the 3rd. So here you cancel. 8 cancels 16, 2. So we have minus 35 times 2, 70. X to the 4th, y to the 3rd. So the coefficient of x to the 4th, y to the 3 is a, minus 70. Question 29. The operation that triangle or delta is defined on the set T equals PQR by the table that. Find the inverse of the element Q under delta, or under the operation. Well, to find the inverse of Q, if you call it Q inverse has this property that when you take the the operation of Q inverse with Q, you're going to get a special number called the identity. And when you take the other way also, when you now take it this way, you still get that special element called the identity. And the identity is the element that when it's applied to another member of the set, it doesn't change it. So looking at the table, you can see from here, if you look at this row of the table, what do you see? You see that Q times P, or Q delta P, is P. So Q delta P didn't change P. Q delta Q is Q, it didn't change Q. Q delta R is R, it didn't change R. And then when you look at it the other way also, you have this column. So here too, you see that P delta Q is P. So P wasn't changed. We have Q delta Q is also Q. So Q wasn't changed, and R delta Q is R. So R wasn't changed. That means that this special element that we are calling the identity is Q. because Q is that special element that whenever you multiply or take the operation of Q and an element, it doesn't change that element. All right, so the identity is Q. And the question is, what? So if you have Q, the inverse of Q, and you operate on that with Q, and you get the identity, which is Q, the question is, what element of the set is such that when you put it here and you take the operation with Q, you get Q? And the answer is Q. Q is that special element. When you take Q delta Q, you get Q. And now let's look at it the other way. If you now take Q delta some special element called Q inverse and you get Q, what is that special element that is giving you Q? And again, the answer is Q. Sorry. So yes, it's Q, but not that Q. It's this Q. So here, this is it. So when you take Q delta Q, you get Q. So the inverse of Q under the operation is C, is Q. All right. Question 30. A force of 40 Newton acts on a particle of mass 8 kilograms, which is at rest. How far will the particle move in 4 seconds? So here from Newton's second law, we have the famous equation F equals ma. And we are given a force. F is the force. We are given the force as 40 Newton. So let's write that here. We are given the mass as 8 kg. Let's write that. But we are not given the acceleration. So that's what we're supposed to find. We solve this. We divide both sides by 8. So the acceleration is 5 meters per second squared. All right. And now we are looking at how far the particle is going to move in 4 seconds. Well, so here we are looking for distance. So we use the equation of motion involving distance. That's S equals ut plus half at squared. So using this equation of motion, we have that our u, which is our initial velocity, because the particle is at rest, the initial velocity is 0. We already found our acceleration to be 5 meters per second squared, and we found that, and we are given the time as 4 seconds. So if we substitute these values into this equation, what does it give us? It gives us, let me write that in a different color. It gives us S, which is the distance, equals U, which is 0, T, which is 4, plus half A, which is 5, and then T squared, which is 4 squared. So we have 0 times 4, 0. We have half. We have 5. 4 squared is 16. So we have 0 plus half of 5 times 16. That becomes 5 times 8, which is 40. So the distance is going to be 40 meters. Let me write it well, 40 meters. So that gives our answer as C. That brings us to the end of this portion where we go through the questions in the 2026 WASSCE Elective Maths Paper 1. As usual, you can find more material for practice and study at our website, preppyonline.org.